Welcome to your lesson on error propagation. Today we are going to look at and understand how rounding affects your calculations. So for example, let's say that this pencil is measured to 8 centimeters, but this has been rounded to the nearest centimeter. What is the largest possible length of that pencil? Now if it was 8.5, that would round up to 9. Anything less than 8.5 would round down to 8 centimeters. So we could say 8.4, 9 recurring would be the largest possible size of that pencil. Or mathematically, it's better to write x is less than 8.5. It can't be 8.5, but anything less than 8.5 is okay. What about the smallest possible size it could be? We know that 7.4 would round down to 7, 7.5 rounds up to 8, and therefore that is the smallest it could possibly be. And we write this as a bounds of its lowest and highest, the maximum and minimum values. We write it like this. X, being the length of the pencil, can be greater than or equal to 7.5, but less than 8.5. Okay, another example then. This bear weighs 160 kilograms to the nearest 10 kilograms, and it's asking what is the range of possible weights for the bear. So same as before, what is the maximum weight the bear could weigh? If it was round to the nearest 10 kilograms, we could say 164 kilograms, 0.99999, or 9 recurring, would be the maximum it could weigh. Like we said before, in maths we can write that as x is less than 165. It cannot be 165, but it can be less than 165. Lowest possible weight then would be 155 kilograms. And so the range of possible weights that this bear could be would be anything greater than 155 or equal to, and anything less than 165. This represents the range of weights that the bear can be. Now with the basics out of the way, we can have a look at adding and doing some other calculations with these bounds. So this triangle has lengths of 3, 4 and 5 centimeters, but these are all rounded to the nearest centimeter. And it's asking for the range of possible lengths for the perimeter. So the minimum it could be is the 3. Minimum value of the 3 could be is 2.5 plus, looking at the 5, the minimum that can be is 4.5, and the minimum the 4 can be is 3.5. And you add those up. That will give you the minimum value. Maximum it could be 3.5 plus 5.5 plus 4.5. Add those up and that will give you the maximum value. We pretty much just added the minimum values all together and we've added all the maximum values together. That gives me the range of possibilities 10.5, that's the minimum values added together, and 13.5, the maximum values added together. And that just means when we're adding with bounds, you just need to do the maximum values added together to find the maximum value overall, and the minimum values added together to find the minimum value overall. So have a go on your own then. Each of these sides are rounded to the nearest centimetre. Can you calculate the range of perimeters for each one? Pause the video, have a go at some. And here are the answers. If you got these correct, you're more than ready to move on to the next stage. So the next stage is multiplying bounds, and this works in this very similar way for adding. The dimensions of this rectangle is 15 millimeters by 18 millimeters, and these are all rounded to the nearest millimeter. What is the smallest possible area the tile could have? We used the lower bounds for each one and multiply them to each other. So 15 millimeters becomes, its lower bound is 14.5 times by 18 millimeters becomes 17.5. They're the lower bounds of each one. That gives me the answer 253.75 millimeters squared. Largest possible area, 15.5 times by 18.5 gives me 286.75. What is the range of possible area then? Goes between 253.75 and 286.75. Easy enough. And so our method for multiplying is very similar to adding. When we're trying to find out the maximum value, you use the maximum value to multiply them. If you're trying to work out the minimum value, the smallest point, you use the minimum value to multiply them together. Straightforward so far, but when we move on to subtracting and dividing, the method changes a little bit. So onto a subtracting question then, which works slightly different to what we've been doing. Imagine that you have a plank of wood and it's 170 centimeters long, and we want to cut off a 50 centimeter piece from that plank of wood. If these measurements are given to the nearest 10 centimeters, what would the largest possible size for the remaining piece be? So if we think about it, we want the largest possible size. So to get that, we want to use the largest overall size of the piece of wood, which would be 175, the upper bound of the total length, and we want to subtract the smallest possible piece. So we want to take away the smallest possible piece. That would be 45, the lower bound of the piece we're cutting off. So this time we're using the upper bound of 1 and we're taking away the lower bound. That gives me 130 centimeters. Okay, this time we're working out the smallest possible piece. Again, think of the overall piece. We want to start with the smallest piece and then take off the biggest possible piece. So we're starting with the lower bound, which is 165, and we want to take off the upper bound, which is 55. That gives me 110. And so hopefully you can understand why when subtracting with bounds, if we wanted to work out the largest possible value, we would do the maximum value of one and subtract away the minimum value of the other. If we're trying to work out the smallest possible, we use the minimum of one and subtract away the maximum value. So, did you understand how to do it when it's subtracting bounds? Let's see. This question, we've got an 80 centimeter plank of wood and we're going to cut off 15 centimeters. All measurements are to the nearest centimeter. Calculate the upper and lower bound, so the full range. Pause the video, give it a go. Okay, answers 64 and 66. If you got that correct, well done. And then finally we've got dividing, and that works similar to subtracting. We want the maximum value, we do the maximum value divided by the minimum value. If we want the minimum value, we do the minimum value of one divided by the maximum value of the other. Now this is a very popular way for the exam to set out the question. They'll give you the values of A, B, C and D, and this time around it says that each of these are measured to the nearest centimetre, and do these calculations. We're going to do an example for this one because we haven't done a dividing example yet, and we want to work out the full range. So let's do the lower bound first. The lowest possible value when we do B divided by C. So we want the smallest possible value for B, which is going to be 19.5, the lower bound of B, divided by the upper bound of C, which is 5.5. Put that into your calculator and you should get 3.55. Upper bound now, the largest possible size I can get. If I do the upper bound of B, so 20.5, and divide that by the lower bound of C, 4.5, into your calculator, that should give you 4.56. So my range of possible values is there. Now, have a go at these questions, particularly if you're going for the top grades. This last question is an A/A star question. Give them a go, full range, pause the video. Right, here are the answers. If you have solved these and you've been successful, you'd have everything you need to know to solve the exercise.